Good morning and welcome back to Advanced Composition with Professor Kent Lee. We are starting on genre analysis this week and a little bit last week. So we talked last time about one aspect of what is distinctive to the writing in the different academic fields. And one of those things is vocabulary. And we speak of the jargon, or a more formal term for jargon is terminology, the vocabulary that's unique to a particular field or occupation or profession. Or more often when we talk about the terminology or jargon of a particular academic field, we sometimes use the more technical term nomenclature. So that of course consists of a lot of special Greek and Latin words that you wouldn't use in normal everyday life. Some very multi-syllable, unusual words that are really unique to a particular field or a couple of fields. But also it involves specialized meaning of ordinary words. And we talked last time about examples of what gravity means in colloquial English, and it means something a little different in physics to a scientist. They think of gravity in a really unique technical way. It's a very specific, specialized way. And the purpose of all of this is accuracy and precision. We have to be very precise in how we talk about things. So maybe pause for a minute and discuss. Think about a particular academic field. Maybe you're taking a couple of specialized classes, especially if you're a third or fourth year student. What are some, in different classes in different fields, so like linguistics, or maybe you're taking literature classes or culture studies classes. So in those fields, what are some examples of special Latin Greek nomenclature? Well, you may not know which language they're from, but they're not words you usually encounter, and they're multiple syllables, kind of long words. Okay, it's probably Latin or Greek in origin. And then what are some ordinary words that have really specialized, technical, unique meanings in your field? So pause and discuss for a while. Now, as we get to the unique characteristics of maybe your field of study, and for this assignment, for this unit, maybe you're taking classes in several different kind of fields. Well, you can pick one or two for purposes of these discussion questions and for the genre analysis assignment that you're going to be doing. You may come across words like theory, maybe model, perhaps law, and perhaps hypothesis. More so if you're in science, social science fields, linguistics, psycholinguistics, you might come across law and hypothesis. In about any field, though, you're going to deal with the theories. In most fields, you're going to be dealing with some kind of a theory. And what does that mean? Because theory means something different in academic English. It is not the same as the colloquial general use of the word theory. For example, you could say, my theory is that my English professor is strange. He must be from another planet. Okay, that might be a theory in the common sense, general sense. But what does that mean? Is that a scientific theory? Would that be an academic theory? What do you think? Well, consider the following terms here: theory, law, model, hypothesis, and especially theory. You may not be able to, especially some of these like model and hypothesis, that might be a little hard for you. Don't worry. Think about theory and law, especially. If you can, model and hypothesis. Is it true that if theory gets proven, it becomes a law? Is that how it works in science? Or in other academic fields? Could you say, oh, I don't need to believe in evolution, it's just a theory, that means it hasn't been proven, so I don't have to believe in it, or you don't have to believe in it. That assumes a theory is something that's not true or not proven. Is that correct? Is that how we use it in academic English? So I want you to discuss these terms. Theory, law, model, hypothesis. What do these mean in academic English? How are they different than in kind of colloquial or general English? And then if you refer to the book, I've got a few examples of some theories. If you can, try to guess what these are about. Theory of evolution. Okay, what is it about? I mean, why did Darwin propose it? And what we follow today is kind of a revised or neo-Darwin. It's not just Darwin, though, is it? It's not just Darwin. People get all hung up on Darwin. It's not just Darwin. He's maybe the first one, but he's not the only one. It's not just his theory. It's just the theory of evolution. What is it about? What's the theory of relativity? You know, Einstein equals mc squared. Is that what the theory is? E equals mc squared. Is that what it's about? Big Bang Theory, Germ Theory, literary theory, game theory, attachment theory. Talk about these for a while. What are these theories about? What are they trying to do? Are they trying to explain something? And then what does theory mean in academic English? And what does law mean? How are they different? Kind of a hard question, but try. How are they different? How are theory and law different? And maybe if you can kind of guess at my hypothesis and model, see if you can try those too. I want you to pause the video and take, these are big questions, so take quite a while. Think about these and discuss these with somebody. Pause and discuss. Okay, when you use theory in the common sense, well, my theory is that my English professor is an alien because he's a very strange person. That's a guess, a conjecture, and it's something that you can't prove. In colloquial English, theory means a guess or conjecture. That's not what it means in science or in other academic fields, in linguistics or psychology necessarily. It doesn't mean it hasn't been proven true. There are a lot of scientific theories that we accept as true. They've been proven true. We still call them theory, and there's a good reason for that. First of all, let's talk about what a law is. A law is a simple statement. And many times when we say it's a law, it's been proven true, but it's a simple statement. It could be a simple sentence, equation, or formula. And it's generally true, at least for its intended domain. So think about, in economics, there's the law of supply and demand. And it basically says that there's a relationship between supply, demand, and price. And it's generally true. It works for normal circumstances. It may not work for like an apocalypse or during catastrophes and disasters, and maybe not so much during wars or such, but it generally works for normal circumstances. E equals mc squared, that's actually a statement, it's a law. E equals mc squared itself is not the theory. It's part of the theory, but itself is a statement of a law about the relationship between mass and energy. And is it always true? As far as we know, yes. We haven't found any cases where it doesn't work. Law of gravity. This is Mr. Newton's law of gravity, and maybe you remember this from middle school or high school, I hope. It's a lovely law. Does it always work? Well, Newton intended it for, of course, the normal world. He did not know about the physics of stars and solar systems and black holes and weird things like that, and how galaxies rotate. But for the normal world, it works. It does start to break down when you get into stuff approaching, the speed of light, or near this, even a fraction of the speed of light, where you have to start to use Einstein's theories and Einstein's equations instead. It doesn't work in black holes, it breaks down in black holes. where it's like gravity just out of control. So this is the law of gravity, and it's true. Now, when Sir Isaac Newton proposed this law of gravity, he was met with some skepticism. Do you know why? Well, some people said, Mr. Newton, okay, what causes this gravity stuff that you're talking about? Can you explain it? Could he explain it? No, he had no explanation for it. He had a law that says, here it is. This describes the attractive force between two bodies, or two objects, and it works. He couldn't explain what causes it. And for that, you need an explanation. An explanation is more complex than a law. A law is a simple statement. An explanation is more complex. It consists of maybe several different statements or propositions, or even equations can be part of a bigger explanation. That explanation is what we call a theory. A theory is designed to explain something, and it's more complex, so it's more of a framework. It's kind of an explanatory framework. So we can define theory as an explanatory framework, or an explanatory conceptual framework. The first theory of gravity came from, guess who? Mr. Einstein. Not the E equals mc squared part, but it's part of Einstein's general theory of relativity. So there's actually a special and general theory of relativity. The general theory includes gravitational theory, at least on a cosmic scale, what causes gravity. Einstein was the first one to come along with an explanation for gravity and what causes it, and how is it related to other things, what makes it work. So the theory of gravity is a framework and consists of several different statements and equations, and they cohere together into a very nice, coherent conceptual framework, and then explain something. Gravitational theory. Okay, let's take, for example, the theory of evolution. It consists of multiple statements. One of them is about natural selection that is often misunderstood. It's not survival of the fittest. Darwin never said that. Biologists don't actually use the term survival of the fittest. They talk about natural selection. Survival of the fittest is not a biology term. It was coined by a sociologist in the 1800s who was a very conservative sociologist who was a big fan of pure capitalism, unrestrained capitalism. So it was he who created, I forget what his name was, Schlesinger or something. He came up with this phrase to justify sort of cold capitalism with no protections for the little people, no regulation. So, hey, if your business fails and you're starving on the street, your problem, you didn't succeed. If you die in the street, tough luck. This is survival of the fittest, baby. But if that guy succeeds and becomes a billionaire, he deserves it because he was smart and he did everything right and he succeeded. That's not Darwin or any kind of biological evolution at all. The theory of evolution contains several kinds of ideas or statements. One is about natural selection. There's another about complexity, from simple to complex. That complex life forms come from simpler ones. There is now, since Darwin, a part about genetic change or mutation. The word mutation gets misunderstood. It simply means change. Okay, changes arise. If you don't believe me, look at the coronavirus. That's a mutation. It is a coronavirus that has mutated to become much more infectious than its other ones. Viruses and bacteria mutate all the time. They change. Not all mutations are good, but sometimes a mutation happens that makes something more successful. I like this new coronavirus, the COVID-19 virus illness. That's mutation. And since Darwin's time, we've also added a couple of other bits of explanation to the theory of evolution and how it works, what makes it work. So what was Darwin trying to explain when he proposed the theory of evolution? The theory of evolution is designed to explain the diversity and variety of life forms on this planet. Why are there so many? Why do they look similar? Why do they look different? There are similarities and differences when you compare different species. Why is that? And how do you explain the complexity of life? Does it explain how life first began? No, that's not what the theory is about. It simply is dealing with life forms once you have life and what happens with life. For how did life first begin? What is it, maybe 3 billion years ago or whatever, in some maybe little tidal pool or deep in the ocean or something. That's a different theory which scientists are still working on. They don't have that yet. That's a harder question, but the theory of evolution has been proven time and time again. And if you don't believe me, look it up. Theory of relativity, well, is actually a special theory in the general theory of relativity. Special theory deals with mass and energy. E equals mc squared is part of it, and there's more to it. Then the general theory of relativity that deals with space and time and gravity and energy and stuff like that. How are they related? Is the theory of relativity relevant to you? Do you use it in your daily life? I bet you do, and you don't know it. If you use navigation apps on your phone or your car, your parents' car, that only works because we know about relativity. Why? Think about the Earth. Your phone communicates with at least 2 satellites up in space. Do those satellites experience time the same way you do down here on Earth? No, they don't. There are 2 different relativistic effects. One, because they're in low gravity, and 2, because they're going really fast. I mean, you're kind of stationary. The Earth is moving. You don't feel it, though, but satellites are moving around very fast in order to stay above us. So they're moving really fast. So there are 2 different time effects. And the GPS or navigation has to use 2 different I think it's maybe 2 different equations from relativity to make corrections for these time differences. Otherwise, it wouldn't work at all. So if you use navigation, it's thanks to Mr. Einstein that we can do that. Navigation apps. Big Bang Theory, it's an explanation of how the universe began. It doesn't say what happened before the Big Bang, that we would turn to other theories for that, which they're still working on. But it's about the beginnings and development of the universe. There's more to it than that, but look it up. Germ theory. Can you say, oh, it's just a theory, I don't believe it? Well, it's a theory that explains infectious diseases. How are infectious diseases caused and transmitted? They're caused by microbes, bacteria, and viruses. And if you don't believe in germ theory, okay, go ahead and expose yourself to coronavirus or whatever. It's been proven. It's a theory that's been proven since the 1800s. Yes, Mr. Pasteur and others met resistance at first. Some people didn't want to believe them. But the science has pretty much proved them right very easily. We know that infectious diseases are transmitted by viruses and bacteria. So the germ theory explains how they're transmitted, different kinds of transmission, different kinds of infectiousness and such. Okay, moving to humanities, literary theory. Okay, something different. If you're taking literature classes, you're getting exposed to literary theory. What is it? It's a set of principles, a general set of principles for how you interpret literature and how you interpret different genres and subgenres of literature, how you interpret poetry and figurative devices in poetry, how you interpret novels and short stories and things like that. And there's general literary theory, and then there are some other more specialized literary theories for special cases. If you're analyzing a novel by an Asian American writer, for example, so you're dealing with Asian American cultural issues and Asian American characters and cross-cultural issues, there are cross-cultural literary theories for that. There's queer theory for gay, lesbian, transgender, bisexual issues or authors. There is feminist theory in literature, and so on. There are a number of other different specialized types of literary theory, which you might get into if you pursue graduate level studies in literature Game Theory, you see the movie Beautiful Mind. It's a great movie. It's about the life of a famous mathematician named Thomas Nash. Brilliant man. The movie unfortunately focuses on his mental struggles, his struggles with his mental health issues in his family. Sadly, it doesn't tell you why this guy was famous. He came up with game theory. You may have heard of prisoner's dilemma. There are, 4 situations, these 2 prisoners, they can kind of tell on each other or give up the other person or something, what happens to them. That's just a small, tiny part of game theory. It's actually a fairly sophisticated theory about decision making, how humans make decisions in a competitive environment. In the prisoner's dilemma, you got 2 prisoners who are possibly competing with each other, and how are they going to decide? Or if you're buying stocks, but a bunch of other people want to buy the same stocks, what are you going to do? How do you make your buying decisions? So buying decisions in complex and competitive environments. That's what game theory is about. It's a very important theory in economics. And that's why the guy got a Nobel Prize. Attachment theory is a theory in psychology that explains emotional attachment. Babies in the first 3 years of life need to form an emotional attachment with a mother, father, caregiver of some kind. And what happens if the baby doesn't form a close attachment, an emotional bond or attachment early in life? Well, later in life, that baby grows up, the person is going to have certain kinds of difficulties in personal relationships, especially close, intimate personal relationships. And it predicts several different kinds of attachment problems. And this is pretty much accepted by psychologists because there's a lot of evidence for this. So these are theories that have mostly been proven true. There are some other theories you might hear about, like string theory, that's a big one in physics now. It would go beyond Big Bang Theory and explain a lot of other big questions that we can't answer. Has string theory been proven true? No, it's really hard to test. A lot of these scientific theories have been proven true. Evolution, general relativity, Big Bang Theory, germ theory. Now, in literature and humanities, do you try to prove a theory is true? Do you have to prove literary theory? No, you don't. In humanities, it works a little different oftentimes. In science and social sciences, we expect to be able to test a theory and prove whether or not it's true. That's not so in fields like literature, where the test is not whether you can prove it, but does it work? Does it help us to generate new insights? Let's say you come out with someone comes along with a new theory, a new feminist theory for literature interpretation, dealing with gender, sexuality issues in literature and characters or authors. You wouldn't try to prove it true. It would get accepted by maybe a certain community of scholars. There is, feminist theory actually out there. So it's been accepted by a community of scholars, feminist theory in literature, because they find it useful. They find it useful. It's a useful sort of framework for interpreting literature and how maybe the reader interacts with the literature, how the writer's gender, the character's gender interacts, more the gender issues, social issues dealt with in pieces of literature, feminist issues and such. It's been accepted by a community of scholars because it works. It generates new insights for them. It helps them to come up with new analyses or new insights into the literature and how it works, how the literature works, how it functions, how it engages with the reader, how the reader interacts with that. And that's literary theory. So in literature and other humanities fields, it's accepted by a group of scholars because it works for them. In science and hard social science fields like psychology, generally we expect a theory to be something we can prove, and we try to prove it. We'll come back to how you prove it later. A theory, again, is an explanatory framework. So theories in any academic field, a theory in any academic field is an explanatory framework. It's a set of principles or statements that tries to explain something. And in science, there's the additional criterion of we want to be able to prove it true or not. And literature, not so much. Theories are explanatory frameworks, different from laws. A law is a simple statement. Now, you may have had trouble explaining what a model is. That's kind of a hard one because it's used in a couple of different ways. You come across models sometimes in social sciences, especially in business and economics, in humanities fields, and sociolinguistics, for example. So a model can be one of two things, and these are kind of similar. It can be a descriptive framework. It's a framework for simply describing something. It doesn't really try to explain it. It simply is a useful framework for describing and analyzing something. Or it's a descriptive framework that also provides some partial explanation. So for example, let's talk about a business model. So business model might be a convenient model for describing how a certain company works, or a certain kind of business, how it works, or how we expect it to work. It doesn't necessarily try to explain why, but it explains the functions of different things and how they work, how this business works. A statistical model is like an equation, and it explains the relationship between different variables. It might give some partial explanation of why. Well, these two variables interact and they have together they have an effect on this variable, something like that. Statistical model. There is in sociolinguistics what's called the three-circle model of English. It was developed by a linguist named Raj Kachru. He was once a professor at the University of Illinois, where I did my my master's and PhD work. I met him. I regret that I never took his class. I wasn't really into sociolinguistics, and I never took his class. I regret that because he passed away a few years ago. Really sad. He was a really nice guy. But he's got this famous model of the status of English in different countries. So what we call native English-speaking countries like the US, Canada, UK, Ireland, Australia, New Zealand, that's the first circle, or the inner circle, and that's where English is the native language. It's the native language of everyday speakers in most homes, as well as government, business, and education, is the main daily use language. And then you have kind of the outer circle, and that's countries where English is an important second language. Places like Hong Kong and Singapore and India, where it's not like a home language. It's not a language you learn you speak at home, but it's used maybe for education or business or government. So it's more of an institutional language, but it's an important language and you have to learn it to function well in society. And then there's the expanding circle, the third circle. That's countries like Korea and Japan, where it's just a foreign language and you don't usually speak it outside of the classroom. It's mainly used in it's taught, and it's maybe an important language in certain educational contexts, certain business contexts, but not in general. It's a fully foreign language. So it doesn't try to explain why or anything like that, but it's a useful framework for describing the status of English. So it doesn't try to explain why English has a certain status or why it functions in that way in a particular country, but it's a useful framework for describing and for analyzing it, as a starting point for doing your analysis. It's a good descriptive framework for describing the status and the functions of English in a particular country or culture. And then we get to the standard model of quantum physics, and this is more of a partial explanation. So the first three are purely descriptive. They don't try to explain why. This fourth one, it's an important model in quantum physics. It tries to provide at least a partial explanation for the different forces in the universe and the different kinds of stuff that make up the universe, the matter, the different particles, the quantum particles, and the forces and energy. It doesn't explain all of them. It doesn't explain gravity, for example. It doesn't necessarily, it doesn't explain a lot of questions. It does not explain, okay, why do we have these particular variables and values? Why is the gravity constant this value? Why do electrons have this much certain voltage or charge, this much charge? Why are things the way they are? It provides some explanations for some things. And it does not explain dark matter, dark energy. And so to get a fuller explanation, we would then turn to maybe string theory, which we're trying to prove. They're trying to prove different versions of string theory, but the standard model, it's been proven. We know it works. It's just not enough. It explains only some things, and we want more understanding. So we've kind of said, okay, the standard model, we've proven it as of, what was it, 7 years ago with the very last particle. It predicted a particular particle called the Higgs boson, and we found it. Okay, cool. Now, let's move on. Bigger picture. What is there beyond the standard model? And that's where physics is now. So, this is important for you because, one, to be an informed citizen, you need to know this. Especially when we engage in public policy debates about, a certain theory says this is what we should do about global warming, or about how to teach science to our kids in school, things like that. And also for understanding your particular field. If you're a literature person, you're being exposed to general literary theory and maybe a particular special theory of literature. If you're in linguistics, you're probably getting exposed to different, maybe bits of different theories and models in your linguistics learning. If you're in culture studies, you're probably dealing with different cultural theories. Now let's move on to hypothesis. So when the average non-science, non-academic person says, oh, my theory is that my professor is an alien, it's more like a hypothesis. They might think it's a theory, but that's theory in a non-scientific sense. A scientific or academic theory, whether it's literature, linguistics, or physics, or biology, is an explanatory framework. Hypothesis is kind of a specific guess or conjecture. It's a prediction. It's a prediction that you can test. So when you do an experiment, you do a study, you're testing many times a hypothesis. My hypothesis is this. Now, when we do hypothesis testing, the most research in social science, in science fields, in engineering fields, is based on hypothesis testing. The whole paper is about a hypothesis that somebody's trying to prove or disprove. Many times it's based on a theory. It could be a theory that's already been proven and accepted, or it could be a new theory that we're trying to prove. So it could be for testing a new theory. Many times a hypothesis is based on a theory. Sometimes it might be exploratory. I don't have a theory, I'm just going to explore. I have an idea there might be a relationship between these two things. There might be a relationship between the kind of music that parents listen to and their children's success in school. Not a good theory, because actually it's going to be their socioeconomic status that affect that. But you can come up with some kind of a new theory. I'm seeing people doing this. There's this new slang term that's arisen, or this word has changed its meaning in English. I kind of want to explore why. I don't have any theory that would help me here. I'm just going to explore. My guess is this. It's a hypothesis. Sometimes you might create a new theory from testing several hypotheses and proving them, but most often in science and also linguistics and psychology, depends on testing a hypothesis that comes from an existing theory, maybe a theory that a group of people have accepted or we've proven. So most of what we call normal science, normal everyday work of scientists, is just taking a theory that we know is true or we know works and applying it to new cases. So let's take attachment theory. That theory has been proven, but okay, what about how would it apply? What would this theory say if we look at a particular new case that we haven't looked at before? Say, children in a particular minority group in a particular country, and given the unique socioeconomic and cultural factors of this minority group, how would attachment theory work out in this particular subculture? Okay, that would be a hypothesis. It's based on applying or extending an existing theory to a new case, a new situation. That's most of what scientific and social science work is about. It's about applying an existing theory to some new case, a new situation, and coming up with a hypothesis. What would we expect here? Prediction. If you're a biologist and you work within evolutionary theory and genetics theory, okay, what would the theory say about what kind of mutations we can expect in the virus over the next year? That's a hypothesis. Or where did this mutation come from? How did this virus mutate and evolve? What particular mutations caused this? Those are hypotheses. Okay. If you're in a humanities field, you might not deal as much with hypotheses. Well, maybe history, you come up with a hypothesis about why did these two countries go to war in the past or something like that? Or did environmental pressures cause this society to collapse? Those might be example of historical hypotheses. In a lot of humanities fields, you might not deal with hypotheses. You will probably deal with models or theories. Maybe in more like business type fields, you deal more with models. Sometimes theories, in a lot of fields, you're dealing with theories of some kind at some level. So it's important to know these. And as I ask you in the future, in the coming class sessions and coming weeks, to think about your particular field or subfield, think about what kinds of theories or models are important to you, are important in the field. And maybe you don't have a good understanding of those theories yet, and that's okay. You can maybe ask an older student in your department for some advice or help on this. But what are the important models or theories that guide the kinds of things that you study and the kinds of research that people do, the kind of research that you're reading about in your classes, and the kind of work that your professor does? So think about, for example, literature in general, or a particular specialization like poetry, 20th century American and British poetry, modern novels. In linguistics, is maybe syntax or phonology or sociolinguistics. What are the important theories and models? How do they develop? Where do they come from? What are they trying to explain? Think about those before our next session. In our next session, we'll start to tie it together more and talk about what's called a paradigm. I'll see you later.